If humankind is to one day colonize Mars, we will need to learn how to produce most of the food and equipment we need to survive on the red planet itself. This is because taking materials into space is prohibitively expensive. For example, it costs about $54,000, £47,000, for the NASA Space Shuttle to put just 1 kilogram, 2.2 pounds, of payload into Earth orbit. Anything that can be made on planet will therefore save weight and money, not to mention that fact that, if something breaks, astronauts will need a way to repair it on site. A new study has found. Analysis of dirt granules brought back by China's Chang'e 5 spacecraft found that regolith on the Moon contains compounds that convert carbon dioxide into oxygen. Now researchers from Washington State University, WSU, have found a way to 3D print tools and rocket parts using dust on Mars's surface. The breakthrough could make future space travel cheaper and more practical, the researchers claim. Lunar soil could potentially be converted into rocket fuel to power future missions to Mars. The soil is rich in iron and titanium, which work as catalysts under sunlight and could turn carbon dioxide and water released by astronauts' bodies into oxygen, hydrogen and other useful byproducts like methane to power a lunar base. As liquefied oxygen and hydrogen make rocket fuel, it also opens the door for a cost-cutting interplanetary gas station on the Moon for trips to the Red Planet and beyond. In space, 3D printing is something that has to happen if we want to think of a manned mission, because we really cannot carry everything from here, said Professor Amit Bandyopadhyay from WSU's School of Mechanical and Materials Engineering. And if we forgot something, we cannot come back to get it. Along with graduate students Ali Afrozian and Kellen Traxel, Professor Bandyopadhyay used a powder-based 3D printer to mix simulated Martian rock dust, known as regolith, with a titanium alloy. Titanium is often used in space exploration due to its strength and heat-resistant properties. A high-powered laser then heated the materials to over 2000 degrees Celsius, 3632 degrees Fahrenheit, to melt them. The melted mixture was then poured onto a moving platform, allowing the researchers to create different sizes and shapes. After the material cooled down, the researchers tested it for strength and durability. They discovered that small amounts of simulated crushed Martian rock mixed with titanium alloy made a strong, high-performance material that could be used to make tools and rocket parts on the Red Planet.